Welcome back, science enthusiasts. In this video, we will take you through the fundamental principles of chromatography and its various classifications with the knowledge to master this essential tool in scientific research. What is chromatography? At its core, chromatography is a technique used to separate different components of a mixture based on their interactions with two phases, the mobile phase and the stationary phase. The mobile phase is a fluid that carries the sample through the system, while the stationary phase is a solid or liquid that retains the sample components to varying degrees. The differential migration of components leads to their separation, and the resulting chromatogram provides valuable information about the composition of the mixture. The principles of chromatography are based on the distribution of the analytes, substances being analyzed, between the two phases. Analytes with higher affinities for the stationary phase will move more slowly, while those with stronger interactions with the mobile phase will travel faster through the system. Types of chromatography. Now that we understand the basic principles, let's explore the various types of chromatography techniques and their applications in scientific research and analysis. A. Gas chromatography, GC. Gas chromatography, or GC, is a powerful technique used to separate and analyze volatile compounds. The sample is vaporized and introduced into a column packed with a stationary phase. The carrier gas, typically helium or nitrogen, acts as the mobile phase, carrying the vaporized sample through the column. The components in the mixture interact with the stationary phase to varying degrees, leading to their separation based on boiling points and polarity. B. Liquid chromatography, LC. Liquid chromatography, or LC, encompasses a range of techniques that use liquid mobile phases for separation. High-performance liquid chromatography, HPLC, is a popular subtype that offers high-resolution separations and is commonly used in pharmaceuticals, life sciences, and environmental analysis. HPLC can separate a wide range of compounds based on factors such as size, charge, and hydrophobicity. C. Thin layer chromatography, TLC. Thin layer chromatography, or TLC, is a simple and cost-effective technique used in qualitative analysis. In TLC, the stationary phase is a thin layer of an adsorbent material, such as silica gel or alumina, coated on a glass or plastic plate. The sample is spotted on the plate and allowed to migrate up the plate using a liquid mobile phase. The different components separate as they move up the plate, and the resulting spots are visualized using UV light or staining agents. D. Size exclusion chromatography, second. Size exclusion chromatography, or second, is a technique used for separating molecules based on their size or molecular weight. It is commonly used for characterizing polymers, proteins, and other macromolecules. In second, the stationary phase consists of porous beads that allow smaller molecules to enter the pores while larger molecules are excluded and elute faster. E. Affinity chromatography. Affinity chromatography is a highly specific technique used to purify and isolate biomolecules based on their specific interactions with immobilized ligands. The stationary phase is designed to have a high affinity for the target molecule, allowing it to selectively bind while other components flow through. Afterward, the target molecule is eluted under specific conditions, leading to high-purity samples for further analysis. F. Chiral chromatography. Natural chromatography is employed to separate enantiomers, which are mirror image isomers that have identical physical properties but differ in their biological activity. Chiral stationary phases are used to differentiate between enantiomers, making it an essential technique in pharmaceutical and biochemical research. Real-world applications. Now that we've covered the fundamentals and classifications, let's see how chromatography impacts our daily lives and scientific research. Chromatography plays a crucial role in various industries and research fields. In pharmaceuticals, it's used to analyze drug compounds for purity and potency. Environmental scientists employ it to detect and quantify pollutants in water and air. Food scientists use it to ensure the safety and quality of food products. Forensic experts rely on chromatography to analyze complex mixtures found at crime scenes. These are just a few examples of how chromatography contributes to advancing science and improving our lives. Before we conclude, here are some essential tips to help you succeed in chromatography. First, ensure proper sample preparation to obtain accurate results. Choose the appropriate column and mobile phase based on the separation requirements. Understanding peak resolution is critical for achieving reliable and informative chromatograms. Lastly, maintain the chromatography equipment regularly to ensure optimal performance. Remember, mastering chromatography takes practice and experimentation, but it opens the door to endless possibilities in scientific research and analysis. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more exciting content. As always, stay curious, keep exploring the wonders of science, and until next time, happy chromatographing.